One of the big challenges of microservices is that there are more things for us to monitor. Your microservices might be running as dozens of different processes across many different host machines, and you don't want to have to individually connect to every worker node in your virtual machine cluster and examine individual log files for every microservice. Instead, what we want is a system where all of our monitoring, telemetry and logs are available in a centralized place. Ideally, we want a dashboard that gives us an instant view of the overall health of the system and the ability to dive in deeper if a problem is detected. Let's have a think about some of the things that we want to be able to monitor. First of all, we want to be able to capture host metrics. This includes things like CPU and memory usage. By tracking these metrics, we can detect if we need to scale out to meet increased demand. Many cloud providers offer the ability to set up alerts based on these sort of metrics, so you can be notified if there are any potential problems. Secondly, we want to track metrics at the application level. So for a web API, this would be tracking the number of HTTP requests, including the number of failures, and tracking what the error codes were. For example, if there were lots of 401 unauthorized response codes, then maybe our system is under attack by hackers. Or maybe we've just misconfigured something. If there are lots of 500 errors, then that points to a bug somewhere in our code. If you're using a message broker, then you'll want to track whether large numbers of messages are backing up in the queues, in which case, again, we might need to scale out. And you'll also want to track whether messages are being sent to a dead letter queue, which indicates that you've got a problem processing your messages. One particularly helpful approach is for each of your microservices to support a health check endpoint. This is a web API that can be periodically called to check your service is running and functioning correctly. It might be as simple as just reporting OK to indicate that it started up successfully. But it can also be useful for your health check endpoints to return additional information, such as whether any downstream dependencies like databases are currently accessible. Third, we need the logs to be easily accessible. Each microservice should be emitting logs, and if those logs are aggregated into a centralized place, that will make your life a whole lot easier. One nice thing about using containers is that they already have a standardized approach to capturing logs, so it's relatively straightforward to aggregate the logs from all the containers into a single place. And there are many products that can help you achieve this. A couple that I've used in the past are sending logs to Elasticsearch and then using Kibana to view them, or in Azure using Application Insights. Many microservice hosting platforms, whether serverless PaaS platforms like Azure Functions or container orchestrators like Kubernetes, already come with lots of easily enabled monitoring and logging capabilities. And that's another reason why it's a great idea when you're using microservices to take advantage of these kind of observability features, rather than having to spend a lot of time creating your own customized solution to these common problems that everyone who's building microservices is going to need a solution to. Let's take a look next at how the eShop on Containers sample application allows us to easily monitor what's going on with our microservices. In this demo, we'll see how the eShop on Containers sample application that we've been looking at throughout this course sends its logs to a centralized service called Seek and implements health check APIs for each microservice that are aggregated together into an overall health dashboard. I'm going to start up the eShop on Containers application locally with the Docker Compose Up command that we saw earlier in this course. And this will start up a container for each of our microservices, along with some additional containers for the databases and other supporting services. And we can see that these containers start very quickly because the images are all available locally on my machine. And Docker Compose Up by default will actually emit all the container logs to the console, so we can already see some of the logging here. But if I quickly go to my browser and visit localhost port 5107, then what we can see here is a health check dashboard. And what this is doing is calling the health check endpoints on each microservice in the system. Of course, because we've only just started up, not all of the microservices have finished their startup yet. And this page is supposed to auto-refresh, but for some reason it's not working at the moment. So I'll manually refresh, and we can see that nearly everything is up and running now, with the exception of WebMVC. What's even nicer about this dashboard is that I can drill down into each of the microservices, and it will tell me whether it's able to contact the dependencies of that microservice or not. And this is incredibly helpful, as it can be possible for a microservice to start successfully, but for it not to be able to do its job properly because it can't communicate with a downstream service. And that might be due to a configuration problem or maybe a transient network issue. Here we can see that the WebMVC service, which is the main website, has started up okay. But it also needs to be able to communicate with the identity microservice, which currently isn't responding. But pretty soon, if I refresh again, we'll see that everything is now working. Not only are all our services up and running, but they're also able to communicate with their dependencies. And so a dashboard like this is a really great way to get a quick, high-level view of the overall health of your microservices application. What about the logs? Well, I can visit localhost port 5340, and we can see here a dashboard showing the aggregated log output from all of our microservices. And this is possible because all of the containers have been configured to send their logs to an application called Seek. Now, this is a commercial product, so you do need to license it if you want to use it in production, but it is free for use in development scenarios. And from this page, I can drill down to see more details of each log message. Seek is designed to support structured logging, so the logs aren't just lines of text, but they can contain additional key value pairs of useful information. So here it's showing us which specific event was being handled when this log message was emitted. And Seek also supports many additional useful features, such as the ability to search and filter the log messages. And Seek is just one example of a product that helps us explore the logs from all of our microservices in a centralized place. And there are several other alternatives that you could choose. But whichever one you select, it will be a huge time saver compared to having to access the logs for each microservice in a different place. In this module, we looked at some of the challenges of getting our microservices running in production. We saw how important it is to automate our deployments, as when you've got lots of microservices, a manual process is just going to be too cumbersome. We saw that you ideally want to set up a release pipeline that allows you to deploy your code into different environments and run your automated tests in those environments, and then finally release it into production once you're ready. We saw that microservices should be independently deployable, and there are several approaches to how you upgrade a microservice, such as rolling upgrades or blue-green swaps that allow you to achieve minimal or zero downtime and the ability to roll back if something goes wrong. Finally, we looked at how important it is that our microservices are observable. We need to be able to monitor host and application metrics, set up alerts to warn us if things go wrong, and to easily examine the logs of each microservice in a centralized place. And we also saw how implementing health check endpoints on each microservice is a great way to enable you to get a quick picture of the overall health of your system. And that brings us to the end of this course. I hope I've been able to give you lots of practical ideas for how you can be successful with microservices in your own projects. Before we wrap up, let me just end with a few final thoughts. First, as we've said before, microservices give you lots of options. In this course, we've talked about things like containers, RESTful APIs, and backend for front ends. But none of these technologies are required for microservices. You're free to choose the ones that make the most sense for your context. And that's important because every context is different. Your task now, if you want to adopt microservices, is to identify the patterns and technologies that make the most sense for the application that you're building. And that's going to take into account the skills and experience of the team that are going to be developing it. Third, in this course, we've only had time to scratch the surface of microservices. And it's also an area that's changing very fast with lots of rapid innovation, and many new tools and frameworks are being designed with the goal of improving the experience of building microservices. So I do encourage you to keep learning. Do check out the rest of the courses on the Microservices Learning Path here at Pluralsight, and I can also recommend this excellent book on building microservices by Sam Newman, which has recently been released in a second edition. And finally, it's likely that your first attempts at building microservices are not going to be perfect. But don't be discouraged about that. One of the best ways to be successful with microservices is to keep evaluating the architecture that you've currently got and gradually evolving it towards some of the improved patterns and practices that we've been learning about in this course.